When your alarm goes off, you grab a glass of water, catch the bus, and start your day. But behind that ordinary routine is a massive ancient supply chain. The water in your glass, the metal in the bus, and the energy moving it all come directly from the raw materials of the earth. We often think of resources as the final products: phones, cars, electricity. But these are human-made. They only exist because we extract natural resources, the raw dirt, water, and minerals, to build them. Think of Earth as a bank account with two assets: income and savings. Income is renewable resources, nature's continuous deposits of sun, wind, and rain. Savings are non-renewables, like coal and oil, deposited millions of years ago. Once withdrawn, they are gone forever. The central tension of modern human civilization comes down to an accounting problem. We are currently spending our deep geological savings faster than our daily renewable income can cover. This pie chart illustrates the specific recipe of our primary biological income, the air. It shows an atmosphere composed of 78% nitrogen, 21% oxygen, and 1% trace gases. Trace gases are elements that make up less than 1% of the atmosphere, like argon and carbon dioxide, but they play a critical role in regulating global temperatures. That exact chemical ratio is required to keep us alive. But when we burn fossil fuels for industrial manufacturing, we pump excess carbon dioxide and unburnt smoke particles directly into the sky, physically altering the recipe we rely on to breathe. This volumetric comparison shows another critical limit. If we shrink all the water in the massive global oceans down to scale, all of the accessible, fresh water we can actually drink and use for crops fits into this single tiny droplet. Humans have known about this scarcity for centuries. To capture that highly valuable freshwater income from the rain, ancient engineers built massive infrastructure, like these intricate stepwells in India, designed to harvest and protect water trickling through the stone. Almost all of these renewable streams, the rain, the wind, and the breathable air, are driven by a single engine: the sun. This flowchart maps how solar energy actually powers you. The sunlight physically transfers its energy into a plant during photosynthesis. A grazing animal eats that plant, and eventually humans consume the plant or animal. Every calorie you burn started as a ray of sunlight. Forests are the physical infrastructure that process all this sunlight. They absorb carbon dioxide to build their trunks and release oxygen back into the air. Their roots hold the soil together and filter rainwater deep into underground aquifers. Local communities have long understood that living forests provide more value than dead timber. In the 1970s, the Chipko movement in India saw women physically wrap their arms around tree trunks, placing their bodies between the forest and the axes of commercial loggers. Our renewable income will keep flowing as long as the sun shines, but the quality of the air we breathe and the water we drink depends entirely on how carefully we manage the ecosystems that generate them. Now let's look at Earth's savings account. The dirt beneath your feet seems infinite, but soil is a slow-forming geological resource. It takes centuries of wind, water, and temperature changes to physically fracture solid rock into a fertile layer capable of growing food. Deeper underground lies another form of savings. Millions of years ago, prehistoric plants and microscopic sea life died and sank to the bottom of ancient swamps and oceans. Over eons, immense geological pressure crushed that organic matter into the dense, energy-rich liquids and rocks we call fossil fuels. Nature spent millions of years building those deposits. Today, humans extract them with massive open-pit mines and heavy machinery, pulling millions of tons of coal and ore out of the ground in a matter of hours. Burning those geological savings has an immediate atmospheric consequence. The process rapidly releases greenhouse gases, gases that trap heat in the lower atmosphere, driving rapid global climate change. We also see the toll on the physical landscape. When we cut down biological resources like timber faster than the forest can regrow them, we are liquidating an ecosystem, turning a renewable income source into a depleted savings account. To stop burning our fossil fuel savings, modern technology offers solutions like the electric vehicle, or EV, which runs entirely on a rechargeable battery instead of an internal combustion engine. But an EV only eliminates emissions at the tailpipe. If the local power grid charges that battery by burning coal, the car is still running on finite savings. True sustainability requires charging that vehicle with renewable income. This Earth ledger shows our global trajectory. Massive extraction drives the savings bar into a dangerous red deficit, while income remains untapped. The structural solution is a massive budget shift. Civilization must rely on our continuous renewable income, halting the drain on geological savings. We already have the scalable infrastructure to capture this income. Dense arrays of solar panels installed on modern rooftops actively convert incoming sunlight directly into the electricity needed to power our cities. And the ledger is balanced from the bottom up. Small human choices, turning off a tap, fixing a leak, taking a bus, or using a solar water heater, compound globally to significantly reduce the daily drain on Earth's reserves. Moving toward Earth's renewable budget allows human development to continue while keeping the planetary account solvent. By living within these biological means, we ensure that our global treasures remain full for the generations following us.